You are making great progress in your quest to become chemists. So far, you can write the formulas for molecules. You can take a chemical equation and balance it. And today, we're going to go a little step further. And if you are given just the words, just the sentence for what the reaction is, you're going to take that and you're going to put it in chemical symbolism. Now we're going to get to the point where you might be able to take just the reactants. You might be able to be given this is going to react with this, and you can tell us what it makes. But that's not for today, but we are going to get there. Now, for today, we just want to be able to take what they call a word equation, a description in words of what's going on, and you take that and put it in chemical symbolism. So that means that you are going to put it in the same kind of symbolism that we've been using to balance chemical equations. Now, in order to do that, you have to know how to write the chemical formulas, and you do. You know how to write the formulas for molecular compounds and for ionic compounds. So as you do this, you might want to have those notes handy in case you've forgotten a little bit of it. So when you have a compound that has prefixes in it, then you know that's molecular, and you can just use the prefixes to write the formula, and that's the easy one. If you have a compound and the name has no prefixes in it, then you know it's an ionic compound, and then you have to think about charges. You have to identify what are those two ions, what are the charges on those two ions, how do I write a formula so that the charges are balanced, and then reduce the subscript so that it's the lowest whole number ratio. So you know how to do all that, but now you're going to have to do it in the context of a larger thing. And then there'll be a few other little things that we throw in there. But before I go too far, there are some compounds, there's some compounds that you need to be able to recognize by their common names. Right now, there's only two of them, and one of them is water, and so you'll be happy to know that that's something that's already familiar to you, water being H2O. The other one is ammonia, which is NH3. So I would like to have you memorize that. When you see the word ammonia, that means NH3. Now, there are lots of elements that don't exist as individual atoms. And what I mean by that is even when they're not in a compound, they bond together with other atoms. And the ones that we'll be concerned with this year that I want you to know are this group of 7A elements. So this is the whole column that we call 7A. And fluorine, chlorine, bromine, and iodine. When those exist as elements, not in a compound, they always exist as diatomic elements or diatomic molecules. There's a few others that do this also: nitrogen, hydrogen, and oxygen. And these are three very common gases, and they are diatomic not because they are gases, but just because the way their electrons are arranged, they're more stable if the two atoms get bonded together. Remember that we had to make octets. Not too long ago we were studying that, and that molecules are more stable if their atoms all have 8 valence electrons around them. And that's what this is about, really. Because oxygen, as you know, has only 6 valence electrons, so it would really like to share a couple more. So two atoms get together and they form what's called a double bond. They share 2 pairs of electrons. Hydrogen has only 1 electron, but it would have a complete valence shell if it had 2. So it shares another one with another hydrogen atom. So we have 2 hydrogens bonded together, and both of those atoms think they have 2 electrons. Same thing happens with nitrogen. Nitrogen has 5 valence electrons. It would kind of like to have 8. So nitrogen forms a triple bond. So they share 3 pairs of electrons. 2 atoms get together and share 3 pairs of electrons. And you don't have to remember all that, but you do have to remember that when you are told you have nitrogen in the reaction, you write it as N2. You don't just write it as N. So this material up here is material that you're going to have to memorize. So if you need to pause the video, do that and get that down, and then we'll go forward. So let's take a reaction that you are already familiar with because we've used it before, and that's the one with sodium and water. So you might be told sodium reacts with water to produce sodium hydroxide and hydrogen gas. All right, so we'll take this as an example and learn a whole bunch of stuff. So first of all, what do we know about sodium? Well, we know that it is a metal, and we know that its symbol is Na. So we'll write that over here. That is one of our reactants. Sodium is going to react with water. We know the chemical formula for water. It's H2O. To produce sodium hydroxide. I don't see any prefixes in that, so that means it must be an ionic compound. So I think to myself, okay, what are the two ions in sodium hydroxide? Well, hydroxide is a polyatomic ion. I remember that because I memorized it. And sodium is a metal that is in group 1A, so it has a +1 charge. So sodium with its +1 charge can be combined with hydroxide with its -1 charge. And just thinking about it in my head, I can tell it's going to be a 1-to-1 ratio, and so I don't need to stop and write any subscripts for that. But I do need to think about it because sometimes I will need to write subscripts. And hydrogen gas, and just a minute ago we said that hydrogen is one of those diatomic elements. So from what we've got here, well, first of all, we know we're going to have to balance it. And we did this last time, so we already know that we're going to put 2, 2, and 2, and that's going to make it balanced. I used that as an example in the video where we were learning to balance chemical equations. So, what do we know about this? We know that anything on this side is called reactants. So that is a vocabulary word. Reactants are the things we start with. They're the things on the left-hand side of the arrow, and that's the before situation. Anything on the right side of the arrow is called a product, and it is produced by the chemical reaction, and that would be the after situation. So before the reaction we have this, after the reaction we have this. You can check if you want, but I'm pretty sure if you count up the atoms, there'll be the same atoms over here as there are over here, but they're just rearranged. Now how about that arrow? If you were reading this, you would read yields. So if I were to be given this, I would say 2Na plus 2H2O yields 2NaOH plus H2. That's how you would read that. If you're using a word equation, they often will say something like to produce, and that's your hint that now we're moving on to products, or to make, or to form, something like that. Now, another thing that we can do, and I'm going to erase this so that I can write in a couple more things. In a chemical equation, we can show the states. And by states, I mean the physical state, solid, liquid, gas, or aqueous. Solid, liquid, gas, we're real familiar with that. Aqueous means it's a solid that has been dissolved in water. And that's pretty important because a lot of times compounds are not going to react with anything if they're just solid. In fact, well, never mind, that's a liquid anyway. But sometimes you can get two solids, and if you just threw them together, they wouldn't react at all. But if you dissolve them in water and then put them together, you get a reaction. So saying that it's aqueous is important. Well, we know that this is a metal, and with the exception of mercury, all metals are solids. So if I want to show that this is a solid, I write a little s in parentheses like that. And if I were to give you something like this, I would expect that you can do that, because I would expect that you are smart enough to know that sodium is a metal, because we've already talked about where the metals are on the periodic table. Most of the periodic table is metals, so when in doubt, call it a metal. And metals are all solids unless you have mercury, which is a liquid. All right, water, you're pretty familiar with water, so I would expect you to be able to come up with the fact that that's a liquid, and that means that we can put a little tiny L in parentheses there. I'll skip this for a minute and come back to it. Hydrogen, again, right up here you're told that it's a gas, but if you weren't told that it's a gas, I would kind of expect that you could use your common sense and say, well, I'm pretty sure that hydrogen's a gas. I know that already because I've lived in the world long enough to have heard of hydrogen. And so you would put a little G there for gas. Now let's go back to this one. This is an ionic compound. All ionic compounds are solids. So whenever you see an ionic compound, you know that it's a solid unless it has been dissolved in water, because most of them do dissolve in water. So we have to think about what's going on in this reaction. Is this a kind of reaction where we've got water? Yes. This is a reaction where I took a chunk of metal and put it in water, and therefore I formed an ionic compound in water. So that going to be called aqueous because we're going to form sodium hydroxide that will be dissolved in the water. Let's try another one. No, actually, if we do that, we won't get any reaction. Let's change that. Magnesium metal. A piece of magnesium metal is placed in a solution of, and now we can use silver nitrate. Whoops, I almost wrote the symbol. Silver nitrate. Silver metal precipitates out, and magnesium nitrate is formed. All right, there's a lot going on there. This is a reaction that we have talked about before when we were balancing chemical equations. You saw this one. So they're telling us to start with that we've got a piece of magnesium metal, and again, we know that metals are solids unless it's mercury. So we can just write magnesium metal as one of the reactants, and that's a solid. It's placed in a solution of silver nitrate. What does that tell us? Silver nitrate is an ionic compound. I recognize that because I see that polyatomic ion nitrate. So silver nitrate's an ionic compound. So my question is it dissolved in water? But they're telling me it's a solution. So yes, that's what that word means. It means that you've got this compound dissolved in water. So we're going to say silver nitrate, AgNO3 in water, AQ. Silver has a +1 charge, nitrate has a -1 charge, so that will be a 1-to-1 ratio, and I don't need any more subscripts than what I had. If I needed a subscript for nitrate, remember I would put parentheses around it and put a subscript on the outside, but I don't need that right now. Silver metal precipitates out. So we've got one of our products is silver metal, which is a solid. And in class we'll talk about precipitates, and I'll show you what that's all about. But essentially a precipitate is when you have something that forms in that solution that won't dissolve in it. And so you see it all come out of solution and kind of sit on the bottom of the beaker. And then lastly, our other product is magnesium nitrate. So this is where I have to think a little bit about charges. So there's magnesium, there's nitrate. Magnesium's a +2 charge, nitrate's a -1 charge. So if I crisscross those, parentheses 2, so the charge from the magnesium gets put as a subscript on nitrate, a little review from what we were doing before. So now we have magnesium nitrate. And that apparently is, it says it's formed. So now I have in this water solution, I have an ionic compound. It didn't say it precipitated out, so I'm going to assume that this didn't precipitate out and it's dissolved in there. I'm going to make it an AQ. I kind of ran out of room, so these symbols do not belong underneath. They belong as subscripts, but I just put that there because I kind of ran out of room. I do get a lot of people that are trying to put them underneath, and that's not where they belong. So again, we ought to balance this. Looks like we'll need a 2 there and a 2 there. But you have a chemical equation. So the difficult thing about this is that you haven't had tons of practice writing formulas yet, and you still have to kind of think hard about it. So it takes a while to do, but you can do it. You just have to go back and remind yourself, how do I write these formulas? And then kind of think through, okay, what about these states? What do I know about these things? So sometimes right in the problem, I would give you what it is if I didn't expect that you just knew it. Like I would expect that if I give you copper, you know that's a solid and you're not wondering, gee, is this a liquid copper? But sometimes if it's a compound that I think you're not familiar with, I would tell you, of course, what it is. So good luck.